Hello and welcome to my tutorial on non-perfect squares. We're going to look at two different questions today, and we're going to look at this one first. It says estimate the following square root. And I've got, for some reason, got a different color pen. Okay. Estimate the following square root. So if you look last week, it will explain a little bit. So last week being perfect squares video, it'll explain briefly what's happening here, but I'm going to just show you right now the step. So we can break up the square root for a fraction into its different parts. So the top fraction or number, which is square rooted, and the bottom number, which is square rooted. Okay. This is probably the second least complicated question we could have for this topic. The only thing that's less complicated is if you only had one of these. So if the question was just asking you to do this, or just asking you to do this, then it would be less complicated. But other than that, this is a pretty simple question. So, for this topic anyway. So we're going to be looking at this, and if you remember from last week, we cannot do a square root of 13. It's a non-perfect square. It'll give us an ugly number. So we're going to actually break up and take a look at the different options for each of these non-perfect squares. So the square root of 13, we're going to compare it to two different numbers, one being the square root of 16, another being the square root of 9, which the square root of 16 is 4, square root of 9 is 3. And we're going to break up the square root of 34 into two different ones as well, square root of 36 and the square root of 25, which is 5 and 6. So we know that 34, the square root of 34, has to be in between these two numbers. And the square root of 13 has to be in between these two numbers. Now what I like to do, especially with estimation, is I like to have a number line. So we're going to just try out a number line here. Sorry about that. So for this 13 one up here, I would start with a number line between 9, that's our lower limit, all the way to 16 being our upper limit. Counting how many numbers are in between, so 10, 11, 12, 13, 14, it's probably not going to be enough. Let's go with this being 15 and 16. Okay, it's roughly even, it's not perfect, but whatever. So we know that the square root of 9 would be 3, right? And the square root of 16 is 4. So we have a number line in between. And to find out what 13 is, draw a line between, and it's almost in the middle between 3 and 4. So it's really close to 3.5. Might be a little bit higher, but it's pretty close. So 3.55, 3.56, or 3.6 maybe, but I'm going to go with 3.5. And now let's take a look at this other one here. Same sort of deal. We're going to make a number line, but I'm going to skip numbers just to make it a little bit easier. So one side is 25, going all the way to 36. Now, counting down from 36, 2 down is 34. Another 2 is 32, 30, 28, and then 26 would be like here, and then this other one here would be 25. Okay, so 25 we know is 5, right? The square root of 25 is 5, and the square root of 36 is 6. Now if we draw a line down from where our number is, 34, well, that's a lot closer to 6 than it is to the 5. And we might even say that maybe this is the halfway. So maybe it's 3/4 of the way to 6. So then we have 5.75, but we want to only have one decimal, so maybe 0.8. Looks like it might be just a little bit beyond 3/4. So 5.8. Okay, so this here was a whole lot of steps just to say that this is roughly equal to, which is our squiggle line sign, roughly equal to 3.5 over 5.8. And if we're doing fractions, we really shouldn't leave it with a decimal and a fraction, so 35 over 58. And if there's any more simplification you can do, you do it, but that looks like that's it for today. Okay, for this question. Okay, so now we're going to look at a slightly more complicated question for non-perfect squares. It's not super complicated, but we'll read it and then we'll take a look and I'll explain. A construction crew needs to get on a roof 2 stories up. Each story is 4 meters. For safety reasons, they must have an angle of at most 60 degrees, which means that their ladder must be at minimum 2 meters from the wall. How long must their ladder be at minimum? So we have, let's draw to shape here, we have a triangle situation. That worked out very nicely. Okay, triangle situation. So their roof is 2 stories up. I'm going to write 2 stories over here. Then it says, oops, stories. Then it says it's 4 meters up. Okay, well, or no, wait. Then it says each story is 4 meters, so which means 2 times 4, oops, undo. 2 times 4 is 8. So it's actually 8 meters up. 2 stories or 8 meters. Let's see what we actually need. We're going to compare to figure out what we actually need. For safety reasons, they must have an angle of at most 60 degrees. So that's this angle here, 60 degrees, which means that their ladder must be at minimum 2 meters from the wall. Oh, okay. So do we even need the 60 degrees? Let's take a look at that a little bit. How long must their ladder be at minimum? So what is it asking for? Well, it's asking for, I'm going to call this L for ladder. Okay, ladder length. How long must their ladder be at minimum? Okay, well, actually, this is pretty good news because we don't care about the 60. Oh, it's really not working out today. 60, and we don't care about the 2 stories. All we care about is the 2 meters and the 8 meters because we have Pythagorean theorem. C squared equals A squared plus B squared. Very important formula that we need to know. C squared is the hypotenuse. So in our case, it's L squared equals 2 squared plus 8 squared. Oh, and it's really nice because L, the unknown, is all on one side already. We don't have to do too much to it. So let's continue on. So 2 squared is 4, plus 8 squared is 64. Add those together to get 68. And now here comes the non-perfect square part, because to do this question, we need to get L by itself. So we need to square root on this side. We need to square root on this side. When you square root a square, it equals just the number, or the, in this case, letter, the variable. So square root of 68. Okay, we don't know the answer to this, but we can do the same method as before. So, as the last question that we did. So, first part would be to find one below. Oh, let's do the one below down here. 64. And the one above is 81. So that's just from us memorizing our perfect squares. So this is 8 times 8. So our answer is 8. This is 9 times 9, so our answer is 9. Okay, now we know that square root of 68 is actually in between these two numbers. So we need to make a number line with these numbers. 64 going all the way to 81. Where is 68 on that? Well, it's pretty close to this side. I don't know exactly how close, but there's a total of almost 20 or so numbers in between, a little bit under that, and it's 4 higher than this side. So let's say it's about a quarter of the way. Okay? But maybe just a little bit under a quarter, so 68. So we know that this one here is 8, this is 9, and 68 is close to this side. So what we do is we say it's roughly equal to 8 right here, but it's just moved a little bit closer to the 9.2. Okay, because we said it was close to a quarter. Alright, so then you can totally box your answer, as I've had some questions about that. I really like it when you box your answers. It makes it easier for me to find them on a test. And that is non-perfect squares. Good luck.